Welcome from the IIBA Tampa Bay, Florida chapter study group. This is our last study group for March 2022. This is our 27th consecutive class. Wow, we're doing great, guys. Our mission here at the IIBA Tampa Bay is to bridge the gap between industry leaders and business analysts by building partnerships with professionals, educators, and employers so that we may empower, instruct, and engage the Tampa Bay IT community. Not only do we work with the Tampa Bay folks, but we work with folks all over the northern half of Florida because that's our area, as well as anyone else who's interested in joining our community. Part of our community's practice is to provide training, instruction, mentorship, and assistance in anything you need. We have quite a number of ways to be able to reach us. One of the things that you might be most interested in is our past recordings link. Our wonderful president has kept that up for us. We have our BABOK study groups every Tuesday from 7 to 8 p.m. Eastern time. We have meetups, Zoom, we have our IIBA site, we have website, meetup, Facebook, two different LinkedIn ways. So if you need to reach us, these are the ways you can reach us as an organization. In the past, on these dates, on these classes, these are the topics that we studied. In particular, these were the study group test questions that we went through. So if you're interested in one of these particular study groups chapters, you can go through this and actually go through those test questions with us. One of the things I value the very most is the conversations that we have in saying, what do you think about this test question? What makes this answer more right than that answer? And sometimes we got caught and we discovered, oh, we missed that word, which will help you whenever you actually take the test to know that you don't want to miss that word. As I mentioned, our wonderful president is here with us. That is Cliff Gray. Lori is our vice president of finance. Caitlin and Priscilla are our board members at large. We do need a new board. If you're interested in being a board member, there's not a whole lot of work to do in most of the positions. Board members at large literally lean in whenever they have time. The other folks have very specific duties that it's a specific number of hours per week or per month, and it's a little bit prestigious being on the board, but it also helps out the community. You also make a lot of connections. My name is Thea Raisins. I'm the Vice President of Career and Professional Development for the Florida chapter. Occasionally, Tiffany Gardner will lean in and help me run this study group. She was instrumental in, say, the first 15 study groups. So we kind of ran this together. But the dude that y'all need to know most is Bob Churchill. Bob has earned his CBAP certification. He's passed the test. He knows what it's all about. He's also earned a whole bunch of other letters after his name, legitimately passing all the tests. Not only has he passed a bunch of tests, he knows what he's talking about. He has a blog that has so much good information in it, not just about business analysis, but about project management, about behavior, about documenting process. I encourage you to go to his website and look it up. You can see we've had a lot of people participate in our classes in the past. I want to be sure we get everybody that's participating in our 27th class here identified. Let's see, I saw a Tish here, right? There you are, my dear. Okay, I'll give you credit for being here. Okay.
And I love your picture, Tish. When your video's not on, the picture of you is awesome.
Yeah. Okay, let me save this so that I know that I don't accidentally lose something here. So today we're going to go. Yes, Bob.
Also have Monica, Amira, and Ilya.
Well, goodness gracious, how did I miss them? Okay, there's
Okay.
Ilya, Amira, and do I have Monica on here yet? I don't see Monica. Am I missing it? The name?
I think she was here last week also.
Monica?
Monica with a K and K-U-Z-Y-N.
Okay. And this week and last week.
I think so.
And 3 weeks ago.
There
I'm sorry?
3 weeks ago.
And 2 weeks ago. So this is your third class?
Yeah.
Very good. Welcome. Thanks for keeping us honest here.
We have someone new, Joanna Cherry.
Hello there. This is my first meeting today.
Did I spell your name right?
Yep.
Okay.
Welcome.
Okay. For those of you who are new, having education hours is important whenever you apply to take your certification test. So whenever you're ready, just contact me and I will be able to say these are the dates that they attended and this is the amount of hours that they have of education credit in pursuit of the test. So I'm keeping this record for posterity and making it available to you whenever you need it. Okay, so for today's
hello?
class, I'm sorry.
Hello?
Yes,
I'm also new. I'm Catherine. Although I'm not from Tampa Bay chapter, I'm from Australia.
that's okay.
Can I be
Catherine.
added in the participants list as well?
Absolutely.
Thank you. That's Catherine with a C.
Okay, there you are.
Thank you so much.
Okay, we gotta ask, what time is it there?
It's 10 a.m.
Oh, okay.
Yeah.
That's not too bad.
Yeah, perfect timing actually.
Great crowd.
Okay, again, one of our favorite things is class participation. So as we go through the techniques that we're going to review today, you asking questions, saying how this technique was useful in your organization or what problems you had with it is very useful to the rest of us that are hearing. So you can see the dates we've gone through some of these that are in green. Today, we're going to go through these that are in magenta. We're going to start with Bob doing data modeling. The next we'll go through prioritization with Ilya. And then we'll go back to Bob with functional decomposition. If we have time left over, I'll start workshops. But Bob is fantastic at data modeling because that was part of his strengths and skills. So let me turn it over to Bob and let him get started. Again, Bob, you're going to put all these on your blog post, right? These articles?
Well, the article is already on there.
All right.
That's where I publish them and I talk straight from them.
Okay.
So many of you who don't know me, I speak a little slowly. I'm getting in touch with my elder Stephen Hawking, but stick with me, we'll get some good information going. So the BABOK says about data modeling, that a data model describes the entities, classes, or data objects relevant to a domain, the attributes that are used to describe them, and the relationships between them to provide a common set of verbiage for your work. I've written about data in a lot of contexts. If you follow those links, you'll see articles and presentations where I've spouted on endlessly about data and getting it, using it, dealing with it, and so on. So feel free to check those out. So dealing with data or gathering data initially comes through two processes. And the BABOK doesn't talk about these directly. It does so indirectly. But I like to highlight these. And I have this kind of 6-phase iterative framework, which is the way I think about doing business analysis the first one is the problem statement or the intended use. The second one is the conceptual model, and that means figuring out what the current as is state, if there is one. And the first thing you do is a process of discovery to learn what's going on in the model or the system or current business process that you're dealing with. You discover the nouns and verbs. So it's all the activities, all the things that are processed, all the people, all the things doing the processes, the machines, and so on. And then once you've identified all that, maybe mapped them all out in a diagram, you do data collection to characterize all those things. So you get numerical parameters, descriptive parameters, statistical things, all that. So all the nouns and verbs, the BABOK actually calls those entities, and that's what you identified during discovery. And then the attributes are what you determine or collect during data collection. You have to do discovery to find out what's going on qualitatively before you do data collection, so you know what data to actually collect. Once you have all those things set up, then you figure out the relationships and associations between them, and you can draw them all up as diagrams. The BABOK identifies 3 kinds of data models, and the way I think about it, they actually are generally associated with different phases of the work. So again, those 6 phases are the problem statement or intended use, the conceptual model, requirements, design, implementation, and test, deployment, and acceptance. So the conceptual data model is the representation you put together of what's going on currently in the conceptual model phase. Ooh, big shock brain. So the logical data model is kind of what you put together during requirements and design, and it's a little bit abstract, and it shows all the relationships and everything that's going on. It contains rules for normalization. By the way, any of you who have worked with databases probably have heard about normalization. Cliff can give you an earful of it, I'm sure. The link that you see there in purple is actually to the Wikipedia article, and it talks about 6 or 7 layers of normalization that you can apply to large data sets. The physical data model is actually defined during the implementation phase, and it shows how the data is formally laid out in memory structures, in the program, in flat files and databases and so on, and where it is distributed on different servers and other locations. So the way I think about doing discovery, I have certain verbiage for things when I identify a current system, I'm used to simulating physical systems. So much of the work I've done is more to do with that and less to do with pure paperwork or information. But if you think about it, whether you're supporting shipping or customer service or sales or maintenance or anything else or medical care, there are a lot of people moving around and supplies and stuff. If you think about all the material that goes in and out of one of our local theme parks, there's 10 times more stuff of that than there is are people going in and out. And I kind of have my own verbiage, like the whole thing is a system. A place where work is done is a station or a process. A group of similar stations, like if you have a whole bunch of entry gates at the entry, you might call that a facility. You have queues where people wait in line. We all know Disney queues on those fun entries, exits, parking lots, which is basically like a queue, but it's not FIFO. It's in, out in any order. And there are connectors between them. All these connectors are very similar, they're paths, they're all shown the same way because they're all for entities to move through. So whether the entities are pedestrians or vehicles or documents or what have you. My verbiage is a little bit different than the BABOK uses, but whenever you're working with your customers and teammates and colleagues or what have you, as long as you identify or agree on the verbiage you use, it's all good. So discovery is where you find out what's going on in these terms. Data collection here, so the center area is kind of another process I cooked. There are people involved with every process that are staffing all of the different sub operations. Some of them are automated, so there are new people shown. And this is an kind of an abstract representation of all the data that goes into describing all those processes, people, stations, and what have you. And that's the comes after the data collection phase. So here is a system I used to, when I was in the steel industry, I would build a whole bunch of systems that shared a similar architecture. So they'd all reserve an area of memory that multiple processes would all reference for their external memory, and it allowed them to talk to each other. It would share messages with other entities, programs, systems, whatever. So I spoofed that with an external test program, and it would send messages using different communications protocols. And then there were a couple of different processes in my system / our system that would read and write 2 disks to defined flat files. sometimes they were databases on the newer systems. That was in the late 90s, I guess. So that's kind of an abstract model, which comes from the requirements and design phase, but it also shows what was actually implemented. So it's actually a physical model as well. So this code listing here is the header file, which describes all the structures and constants in the actual memory map of the shared memory area of one of these systems. And that is detailed. It used a modified kind of Hungarian notation system. There was a naming convention where things like H stood for enthalpy, which is quantity of heat in thermodynamics. T was temperature. So there were a lot of things. L was for logical. There were things for arrays. There were integers. So there are a lot of ways you can do that. In a lot of modern languages, there are very few data types, or you don't have control over the details of a given data type, which is why a lot of things on the internet were wildly different kinds of processors might talk to each other. They say, don't do anything like this at all. Just give stuff names, make sure everyone agrees on how to represent it, and let the software handle it on its own. Talk to your implementation specialists and programmers about that. And here's a physical representation of data, which is a detailed layout of items in records in a database that shows the relationships between them. Many of you are probably reasonably familiar with them. The BABOK actually talks about two very specific kinds of documents or diagrams describing data. One is called an entity relationship diagram using crow's-foot notation, and that has to do with the relationship, whether it's 1 to 1, 0 to 1, 1 to many, many to 1, many to many, and so on. So it's that kind of relationship. The other is a class diagram from UML, which is a modeling language that tries to get you to look at a problem from many different angles. So if you do all the things it tells you to, you might miss stuff, but it's basically a kind of a automated way to get you to be super thorough. So I'm a big fan of actually looking into those specific diagram types. You only have so many questions on the exam. You might not get one about every type, but there'll be one, a handful about specific types, so be aware of those. I more or less punted when I took the exam, but if I had it to do over again, I would prepare it differently. And certainly for the CBDA, which is Certification in Business Data Analysis, they talk about many different kinds of diagrams, and they're be really helpful to look into those closely. And that's all I have to say there. Does anyone have questions? Okay.
I have question
I'd
maybe
like,
to
I'd
all.
like to ask a
all.
question.
Sorry.
Go ahead, Elliot.
Yeah, like in your practice, being a BA, which types of the diagrams you mostly used
Well,
during your
some of
requirement session?
these are my work. So these are systems that I actually built. And I mean, if you look on my roles page under the first two articles are systems analyst and system architect. And there are more drawings there than you could shake a stick at. They're all in Visio. I tended not to do anything that was a specific industry standard. I did what communicated what I was doing for me and for my customers. We reviewed it and I included them in documentation, and that was the basis of our shared understanding of the work. So my rule, not anybody else's, is do whatever gets you and your interlocutors and colleagues on the same page, and there are no rules.
Bob, could you go down and show us the crow's foot notation a little bit more closely so people can see some of those symbols?
It's in the BABOK. I did not show them in this article.
Okay,
Actually, in the BABOK, what I'm reading is they giving this concept three things, right? Conceptual data model, logical, and physical, without any diagrams, without any going into details.
Right.
But of course, that's all you can find in the internet, how to build entity relation diagram, class diagram, and all that stuff. The only thing, I mean, in my experience, I was not going always that deep level, because like the database of the current system can be so complex. It's hundreds of tables. Tables are so huge. It might not be even relevant to your project, right? I mean, those systems, but you're building some functionality which is embedded in that system. So that's what I'm trying to say. You being as a business analyst, you probably won't be able to create some proper interrelationship diagram without asking, you know, your tech lead or architect or some other architect who will actually know the physical databases and all those connections.
Well, the
So
other
you
thing
maybe
that
only stop on the logical piece, like, or for your particular requirement.
The other thing is that I wore a lot of hats. So I was the coder, the designer, the architect, the discoverer, the tester. I was kind of a one-man shop. So depending on the situation, I had a lot of freedom and not many barriers. So I could kind of do what I want. Now, that didn't always work out. You know how politics goes, but I never felt particularly constrained in what I did. That said, at Westinghouse, our documentation was very formal because the systems we built were highly engineered, highly exacting. They were very formal requirements for testing and accuracy and verisimilitude and so on. So it was a multi-stage, very complicated and more costly and time-consuming process of verification and validation and so on. So the larger and more formal the organization, the more cumbersome it's likely to be. And that's only if you imagine the series of communication channels that's like n times n minus 1 of the number of participants. That's how many channels there are. So as projects get larger, the complexity of keeping everything on the straight and narrow kind of increases by the square of the number of participants. So I've gone way over on this one topic, so let's punt. If anyone wants to ask further questions, please feel free to contact me in writing or in any other way.
Bob, is it safe to say that most business analysts won't reach this level of complexity? This is typically an architect or a developer that would need something at this level?
Well, it depends. I mean, if I'm a BA, I want to do everything I can. I want to be as involved in everything I can. I'll sit with the programmers and the architects and be involved. And maybe that's why I had such a problem finding a spot as a BA, because maybe people wanted to find some junior Robotron that'll run around and just do what they say and not work at a very high level. And that's not what I do. And I hope you all, without having the problems I did, aspire to broaden your horizons and your capabilities as far as possible.
Okay, thank
And
you.
I can add to that, Bob. I mean, data is gold now. And anything to do with data, business analysts. Yeah, I've heard a lot of other people in the BA world say, you know, I need to understand data, how it works, what it is, because everything now is being driven by it. So the more you understand data and how it works and how it's related, the better.
Very good. Okay, let's move over to Ilya. Ilya, if you'll talk about prioritization, please.
Yep, sure.
Thank you. I'm looking forward to this. While you're getting that set up, let me explain that whenever we were writing the techniques chapter of the BABOK 3, they were very specific. They wanted us to be descriptive and not prescriptive. So we weren't allowed to give examples for most things. We just had to kind of describe it. And it was a level of frustration that I don't want to experience when we write the 4th version. Okay, this is Ilya. Go for it.
Hey guys, can you hear me good?
Yes, we can.
So in the BABOK, the prioritization obviously described through those four things. Like you need to group. So basically, why do we need this prioritization? We need to plan our work, the pipeline. We obviously cannot complete all the requirements right away. The project will take time, so it will require constant prioritization, especially in the projects like Agile, which use Agile methodology, which building in small increments and very intense projects in terms of the releases. So that prioritization is the key, right? The success to your project. So in the BABOK, they explain to do the prioritization, you kind of start from grouping. You classifying your requirements as the high, medium, low in terms of the importance to the business. Then you're ranking it from the most to the least important, from high to low. The other way is you're doing budgeting on time boxing. So kind of you using you classifying the requirements based on the effort to be put in that requirement, time and money, and then based on that, you can also rearrange the pipeline of your requirements. So, example, if it's very important, low budget, like it's good thing to implement, or you know, that way. And then obviously all of that, once you will going through analysis like grouping, ranking, and budgeting, that brings you to the table with the stakeholders to negotiate the requirement, the prioritization. Like in my projects, basically I'm influencing that. So, and I think the business analyst can and should influence the prioritization projects prioritization process, because the business will tell we need everything to like yesterday. So you would need to work and to show them the importance, to ask the right questions, facilitate from them those answers, which will bring them to the conclusion, okay, that's actually maybe less important or more important. So what I complemented in my presentation, that was actually what's mentioned in the BABOK. That's it. So I complemented it with the other methods which known to the world, to the society. So I want to go through them. Some of them I Googled, some of them I used, like Moscow method on the top. So each story is prioritized based on the following 4 types, like must have. That's something you have to implement, otherwise your solution will not work. Should have, it's something like would be good, but it's not critical. It will not break anything. Could have, the users, and again, that you see that's used for user stories for more agile projects. So the could have, as the user story has value, it's desirable, maybe not that necessary. And won't have is like it's a least critical, but again, somebody wanted that thing. There is another way to do a numerical prioritization. You're just putting priority 1, 2, 3, and basically based on what value that will bring. So 1 is the most critical, 2 less critical, 3 lower priority. What else we have? Well, it's just to summarize. To me, like what we're using, what I use in my projects is that standard way of classifying. It's a critical, it's a blocker, critical, high, medium, low, and it can depend whether you're doing the requirement or you're working on that issues backlog. So in some of the projects, you might have a bunch of your backlog can be 50% of your backlog can be issues, and then you also need to prioritize them. That you can choose a little bit different prioritization based on it's a blocker or not for your project. How, like, if, as I mentioned, like in all my projects, I would range those issues. We'll ask the business, how is it important, and they put 20, like let's say we have 100 user stories, and they will put 100 like critical. And that's, I think, the challenge I was facing always, and some of the people will face some of the time. So how we can how we can get out of this situation, actually implement something, because we'll be paralyzed with that importance and pressure. So we need to still, from those highs, but still need to define which are more high and which are less high. So what I was using, I would be just asking questions, for example, like what would happen if that feature will not be developed at all? And in many cases, actually, the business will be puzzled, and they say, well, nothing will happen actually. So they see the big benefit, for example, implementing, but if it's not implemented, still not critical. So I will ask that question, then I will ask what the dollar impact it will bring to the company if that's not delivered. If business cannot actually articulate that, cannot link it to the money, that to me says, okay, that's maybe also not that important as they think. And again, it's not like I'm taking decision, I'm taking it from them. I'm trying to drive them to that conclusion that, look, guys, you're saying it's important, but actually you don't even know if that will bring any benefit. And third thing, I would always ask if there is any, or we'll brainstorm, is there any workaround possible, right? So if you have all those options, then it's way easier for you to think what is really, really important and then focus on that, and then go to the lower importance. And maybe they're also important, but there is a workaround, which in many cases there is a workaround. And then you can wait for they can wait for some time. You can implement features which you cannot do with any workaround, and then implement the other stuff. Of course, when you're thinking about workaround, you have to consider manual effort, all those costs, if they also applicable to the business, like to work with this workaround, to have this workaround. So basically that's it from prioritization point of view.
Do we have any questions? I'd like to add two things. One is the concept of minimum viable product, or MVP. Whenever you're talking about what is highest priority, if you can get them to identify what the minimum viable product is, that's really this critical stuff. Everything else is not. So that allows them to kind of see it in a different perspective. And one of my favorite techniques in getting people to actually move cards on a board is create four horizontal lines and put all of the, they say all of them are critical, put them all up in the critical, and then have them move some of them down below, down to the not so critical or low or nice to have. And Moscow is a great way to do it, because it's like, okay, they can't all be must-haves. And if you explain to them that the developers have to know what order to work on them, and they want to work on the most important things first, that will give them more incentive to be able to say, not all of these are the most important things, because developers can't work on them all at once. So what should they work on first? So that gives them that perspective. Did you have a comment, Bob?
I was going to say that there were two different considerations. One is an end user feature that the business actually needs. Another is a logically supporting underlying feature that is technically required, and those can be driven by the order in which it makes sense to do the implementation. So be aware of that, and talk to your implementation team about that. All that is implicit in this. You can't do a feature if the background supporting stuff isn't there, but felt it's worth mentioning explicitly.
Yeah, that's very true, actually. So you can define the priorities, but then your implementation expert tells that, no, we have to build this, this, this before we can even go to that stuff. So even for business, it's not, doesn't make any, I mean, they don't understand that, but like you need to build some, I don't know, database, open ports, or something else, infrastructure setup, that could be important. And another thing, just to mention, I just remembered, you said minimum viable product. There is other term I heard, and I'm trying also to use sometimes, minimal marketable feature. So when you have already maybe a minimal viable product, but then you kind of incrementally building more things, then you can talk about minimum marketable features. You have a list of the requirements, which you can group into some feature you want trying to release, but then maybe you can release some minimum set, which will will bring that. You can deploy, you can get that benefit from the business, from implementing it. Plus, you get the feedback from the users, and your full feature deployment will have some already feedback incorporated from that minimum marketable feature.
There is one more
Thank you.
technique I'd like to bring. I'm sorry, Elliot, did I interrupt you?
No, that's it. I actually done. No, thanks.
Okay. There is one more technique that I found is useful, is if you'll get the business to identify the business value in a scale from 1 to 10, 10 being the most important value, mark it on every card. What is the business value of this? And have them, identify, is this a medium? It's a 5. Okay, so this is the most critical, it's a 10. Okay, great. And then also get them to go back through and identify the priority. Multiply those two numbers together. And that gives you a much more granular order of development as far as what is important as far as the business's development. Business development is not necessarily the same as system development. You might need to create the database before you can create the UI or something like that. So, but the business development, the business functionality, if you use those two numbers multiplied together, you have an order of priority. Then if you put it in that priority, you'll discover that in the first half of the project, you'll get the 75% of the highest value accomplished. It's kind of weird math, but it seems to work.
Yep.
Okay, how much time do we have? We are at 46 minutes. Bob, do you think you can do your next one in 15?
I will certainly try.
Okay, go for it. Ilya, that was fantastic. Prioritization is critical, especially in Agile.
Thanks. Thank you.
All right, so I have a lot of pictures here. I'm not going to really concentrate on the verbiage that's in the BABOK. I will mostly speak to examples. So my first actual engineering job was in the pulp and paper industry as a process engineer for a company that made turnkey production lines that turn piles of logs and or piles of chips, run it through a bunch of giant equipment and pipes and things like this to make that. That's back in the days when people still read newspapers. So some of the mills I worked in are gone now. So we can break down everything that's going on into a drawing like this, and every drawing, or we can build up something like this into a drawing like this by knowing about all the individual pieces of equipment. I'll tell you a funny story about this one. This is a screw dewatering press. I may have told you this story before. The guy who designed the version our company sold, he was one of those old timers, genius guys that had 50 patents. And I found one of these in a mill that was so old that a nice metal cover with the windows was gone. And they hung up 2 rods and put shower curtains on either side and cut them down. So that's what kept the water being squeezed out of the pulp from spraying all over the place. So all these machines have details and spec sheets and so on. Here's the machine that did all the work. There's a 5 foot in diameter rotating disc that weighs a couple tons with these tooth plates on them, pressed together under high pressure. You feed the wood chips in, they work their way to the outside, they get turned into the pulp. You can analyze those in as much detail as you want. The design of these things was very detailed. You had to know about the energy. Some of these things use 22,000 horsepower electric motors. So these are large machines. Any piece of equipment, whether that you're dealing with, has many different characteristics. You can break all that down. That's just what's going on the outside of the pump. Let's not even go into everything that's going on inside. So here's a requirements traceability model that works through the 6 or 7 phases of an engagement, the way I think of it. So we relate everything we do, every requirement item, make sure it's reflected in the design, implementation, and test. Everything is cross-linked. We introduce non-functional requirements. Here are some methodological requirements, but also you can imagine things have to be related and organized as you trek through an engagement from start to finish, but they also get related to each other as you break them down from epics into tasks. So that's a level of abstraction you can break down into more reality and detail. And then here, if you have an airplane, you can break it down into even more detail. So aircraft might have 30,000 different kinds of parts and many of each type of part. So they can be very complex. So you can imagine taking this thing, turning it counterclockwise a quarter turn and kind of plotting it from top to bottom, say in the design column here. And that is another way everything has to be related and decomposed. If you have equations that describe your work, you can analyze what goes on by thinking of everything that can possibly affect making every variable larger or smaller, and you can see how that affects the final result. Some equations are very formal. That's the first law of thermodynamics. It's well understood. You spend sophomore classes in it in engineering school. One of the most powerful discoveries of humanity. This is a looser equation. It's more theoretical. It is more it's not a formal equation, but it describes the relationships conceptually to show the price of goods is dependent on the demand for a good and supply of a good. And the demand, the supply and demand for money. So if you're talking about inflation and the changes in the overall price level, Milton Friedman said that inflation is everywhere and always a monetary phenomenon. So if you get inflation, it's almost always from printing too much money. And this is another kind of equation. It is a diagram showing the flow of calculations. So all the different data elements that go into something, all the operations that multiply and sum everything up to get a final result. It's just another very long equation. That was a whole process we did for a staffing model for a large DHS project for ports of entry and land crossings, airports, seaports, and so on, and internal facilities. These are behaviors and decisions. It's a decision tree or a routing diagram of all the destinations something's passing through a process might go to. So when it enters, everything goes to the primary process. Many of those will go straight out. Some will go to this process, some will go to that process. There are other places they can be diverted to. So you can represent this any way you want that makes sense for your project. Here's sort of a random flow diagram for a system that involves different kinds of entities going in and traveling through different inspection processes and exiting. Every one of these boxes has a bunch of this going on. So you have a source for everything. They give you inputs, you have outputs, they go to someplace else. Could be another process or whatever. And going on inside this process, what's going on can be on another map like this. So it really scales down as far as the analysis makes sense. Here is a breakdown of what happened in a process that we analyzed in the insurance underwriting industry. That was a more abstract process that processed tens of thousands of documents, put them in these special folders and routed them to underwriter analysts that could look at these files and score them all to help the insurance company make decisions about whether to extend coverage to a company and how to price it. I showed you this picture before. It's a large manufacturing plant in the steel industry. So this shows the physical flow of material. Each system has a multi-level control system. There's a plant-wide coordination system, and all the business systems are tied in up here. You can break every single one of those down. Every one uses different hardware, different technology, languages, communication protocols. Many people are involved with every aspect of this. So you can decompose that as far down as you want to go. Here is an an architecture diagram that talks about different activities that are going on across hardware to operations. There are protocol layers in here, and it's hard to say much about this from memory, but just know that if you can make sense of it and identify classes both horizontally and vertically, you can see things that there are opportunities for streamlining, filling in holes, doing things the same way and making things more modular and robust. When you're breaking things down and doing root cause analysis, this is one tool people use to do this. It's called a fishbone or an Ishikawa diagram. So you look at 5 M's and an E. Personnel used to be man. We can't say that anymore. So now it's 4 M's and a P and E. So measurement, materials, personnel, environment, methods, and machines. That gives you a starting point to look at categories of things that may be going on, and then you can look at all these things to help identify where things might be going wrong. I love this picture. I share it all the time. And that shows that if you break things down, that allows you to look at things from different angles. And depending on how you examine everything, you have a better chance to see something different. So the BABOK actually talks about decomposition in these in their element section. It breaks down objectives. Here's what you can do within. Here are things that you can decompose. So outcomes, work to be done. I showed you that. Processes, function, business units, parts of solutions, activities, and so on. Levels of decomposition, you can see that you can peel things apart in different levels. And there are as many ways to represent the results of your decomposition efforts as there are creative people making pictures, and list some of those. There are far more. There are examples of some of these above, and that's all I have to say about that for now. Any questions?
Bob, that's a lot of really great information. You got so much depth and detail in that. Great job. If anyone is beginning the idea of decomposition and you feel a little bit overwhelmed, just consider you start at the highest level. Say you're in an airplane at the highest level and you're looking down and you see things and you just see a few elements, and then as you descend, you can see more elements. If you look at decomposition as the idea that you're going to understand it differently based upon what level you're decomposing it at, you're going to see totally different truths, different opportunities from the high level to the medium level to a very fine detailed level. But you have to be at the right level of decomposition so that you can really understand it for that particular thing. And again, you're going to see totally different things at medium than you will at fine. So if you think, I got to get down to the fine level, you've got to make yourself go through the exercise of doing it at a couple of different levels so you can really understand it. And it helps people that think at different levels.
And that's one of the things you'll negotiate with your customers and colleagues is how far down to decompose things. That's part of your assumptions what details you include and leave out. So that's all part of it.
Very good. We are at the end of our time today. We have had some really good content and I appreciate our presenters a great deal. We'll start next week with workshops, and let me share my screen and let's see. We're going to start workshops and something else. Let me double check. Workshops, mind mapping, balanced scorecards, survey or questionnaire are going to be on the list for next week. So we won't probably get all 4 of those done. We'll get 3 out of the 4 done. And we will see y'all back here next week.
All right.
I hope y'all, yes.
Anyone wants to volunteer to do one of these, please contact Thea and put something together. We'd love to hear your thoughts on it. You can't possibly speak worse than me, so don't be bashful.
And doing it from your own experience, or even just doing it straight out of the BABOK, is perfectly acceptable, because your own experience is valuable. You're going to have insight that nobody else is going to have, and it's going to help somebody else. And straight out of the BABOK, it's a page and a half, maybe 2 pages. Just go through it. That's all you have to do, is walk through it for the group and let us ask questions and have conversations. You don't have to have all the answers. You're just doing the presenting. And if you're going to contact me because you want to do something, contact me through LinkedIn, please. My email is just too jammed. I'll see y'all here next week. Y'all have a great week.
Thank you.
Thank you.
Thanks, everyone.
Bye, guys.
Have fun.
Thank you. Bye-bye.